Alright, what's poppin'? Welcome back. So today we'll be doing sim tree, which is an easy question, and also a binary tree question. So given the roots of two binary trees, P and Q, we want to write a function to check if they are the same tree or not. And so two binary trees are considered the same if they are structurally identical and also the nodes have the same values. Meaning, let's say we're given these two binary trees, right? In this case, they'll be the same. Why? Because a binary tree can have maximum of two child nodes, right? That's one thing to note. So the structure is the same, meaning that let's say we have a node, it has two children. If it has two children, the other tree must also have two children here, and all their values must be the same. And in this case, this will be wrong because this node have a left child. However, this node doesn't have a left child. It only has a right child. So these two are structurally different. And lastly, if we look at this is obviously not the same because even though they have the same structure, meaning this one has a left and right child, this tree also have a left and right child. However, their values here will be different because the left child of this node is 2 and the left child of this node is 1. So you can see that is false. So that's just what they mean by if they're the same tree. So how will we actually solve this problem? So the method when we look at binary tree is always, the first thing we should think about, is there a way to do a recursive solution to it? Because binary trees, by definition, they have a very recursive structure to it, meaning that each node here, let's say we take a look at this entire tree, right? We'll take a look at this entire tree. Each node has a left and right node. However, this node could be a tree itself, right? So imagine if we extend this could have a node of 1, this could have a node of 4, right? So we can see that although this whole thing is a tree itself, if you just look at this itself, this is also another tree. So do you see that recursive structure to it? Whenever you look at a left or right node of a node, right, itself is also another tree. So if you're able to find a recursive solution to find one node of it, we can then extend it to the other left and right subtree, applying the same solution because the solution will work on a general tree. Therefore, we can use that recursive structure to find a very elegant solution. And we think about recursive solutions, the first step I would always like to take is to take a leap of faith, meaning we want to assume that the recursive solution works. If we assume that it works, then we can build the base case from that and solve the issue. So let's take a look at exactly what I mean. So in this context, how do we know if a tree is the same? So let's look at this 1 and 1, right? Let's assume this function works, right? So let's say we have a function called same tree, and we assume that if it takes in a node 1, and node 2, let's say it takes in two nodes, it's able to spit out, it's able to give me whether it's true or false, right? If I assume this function works, what can I do with it? Okay, so first let me apply it to this node. So we're gonna call this same tree function on the two root nodes, this node and this node, right? So if I call these two, right, by right it should return me true, right? But we have to look at the left subtree and the right subtree because we're trying to form the base case, right? So if I assume this works, I'm gonna call it on this tree and this left subtree. So by right, originally we are looking at these two trees, right? Let's say we call it on the left node of each of these current nodes. So we call same tree on the left. So we call it on node 1.left and node 2.left. So node 1 being this root node and node 2 being this other node. So node 1 and node 2 will call this same tree function on the left of this node 1 and the left of this node 2. So itself here, this could be another subtree. It could be another tree here, right? So let's assume these functions work. So let's say if this returns me true, okay, this returns me true, right? Meaning we know that the left subtrees are exactly the same. And if you call this on the right subtree, we'll call it on the node 1.right and node 2.right. That means we're going to call the function on these two nodes here, right? So let's say this also returns me true. What does that mean? So if what I'm trying to say is, if the left subtree of both nodes are the same and the right subtrees of both nodes are the same, what does that mean? That means that if these two nodes are exactly the same, that means it has all the conditions for it to be the exact same tree, right? So if the left subtrees and the right subtrees are the same and the value of the node itself is the same, so node 1, so you can see that if all these three conditions are the same, that means the whole tree itself is the same tree, right? Because if the node itself, so we're comparing node 1 and node 2, right? If two of these nodes are the same, so that means if 1 and 1, right, in this case is the same, and also the left subtrees of both are the same, and the right subtrees of both are the same, that means the entire tree will be valid and they're the same, right? So this is a leap of faith. So now we just need to call this and let's see what happens, right? So we'll code it out. So we'll take the leap of faith first, right? We'll ignore the base case, we ignore everything first. So if p.val equals to q.val, so this p and q is just node 1 and node 2. So if p.val equals to q.val, then it will make sense for us to check, right? Because if let's say this is not even 1, right? Let's say this was 5, right? And we check if this value is not even the same as this value, then what's the point of checking the left and right subtrees? We know that as long as one of the nodes doesn't match, the entire tree won't match, right? That means only if these two values are the same, then it makes sense for us to call the same tree function on the left and right node. So if p.val equals to q.val, then it makes sense to ask return self dot is same tree of p.left, q.left, and self dot is same tree of p.right and q.right, right? So if these two values are the same, how do we know if the whole tree is the same, right? The whole tree is the same if the left subtrees are the same and the right subtrees are the same. Therefore here we have this and. So if these two conditions are valid, that means the left subtrees are the same and the right trees are the same, and p.val equals to q.val, then this entire branch will return true. That means the whole tree is the same. Okay, so we have taken the leap of faith. Now let's try to figure out the base case. So in the end, let's say we're looking at this node, right? We're looking at this node. How do we know that we need to stop? We need to stop the search, right? We need to stop the search if, let's say, the passed in node is both are null. So let's say we're at this point, we're comparing here this 2 and 2, right? So let's call this a node.left and node 1.left and node 2.left. So this becomes node 1 and this becomes node 2, right? So now here will be a null value, none, right? Because it doesn't exist anymore. So if these two are the same, right? If the pass in node.left and node 2.left are the same, which means they're both undefined, right? We can say that these two are the same trees technically. So if not p and not q, right, we want to return true, right? So if the passed in nodes, right, they are both null, right, that means they are both at the end of the tree, so we can return true. They are the same tree, because then we want to go and traverse back into the stack, right? And the second case is if this is not true, right, if not p or not q. So now you see the difference here is the n. So this is n and all, right? So if not p and not q, that means if both are none. However, if one is none and the other one does exist, so let's say here is a node called 4, right? So none and 4, right, they are obviously not the same. Therefore, we can say that this whole branch here is false, right? So if one of the values is null and one of the value does exist, right? So if not p or not q, right, we can say that return false, right? Something must differ. And lastly, if let's say we have these two nodes, so if the last case is that if here we have a 5, right? So let's say there exists a nodes for both the left and left, right? If they're not the same value, obviously we also want to return false. So if p.val not equals to q.val, they also want to return false. So we have considered all the edge cases and all the base cases, and if all of these passes, that means they must be the same. So in this case here, let's say they all pass the test, that means they are both true, they both exist, and their values are the same, 4 and 4. Then it makes sense for us to call this function, right? Then it makes sense for us to call whether the left subtree is the same and the left right subtree are the same. Yeah. So let's try running this, and you can see that it runs. So the important trick of finding tree solutions is just to take the leap of faith, assume that the recursive function works, and then ask, what does this recursive function, how can it help me solve the question? Then after taking the leap of faith and finding the solution, then we think about the base case. Then using that kind of methodology, we can find solutions to 3 questions. So I hope that has been helpful to you, and if it does help you, liking and subscribing to the channel will help it a lot. So thank you so much for watching.